Hello everyone, and welcome to our next lecture in our microbiology class, Antimicrobials. This kind of goes into our last chapter that we had before the exam. It leads directly into it, where we learned how to control microbes outside of the body. We will learn how to control microbes inside the body now. Okay, and so how to control them inside the body is we are going to use antimicrobials, however you want to say it. Okay, the function is all the same. We want to get rid of the microbes. Okay, and so how do we do that? Well, we typically use what's called chemotherapy. Okay, and this word probably hits each one of you in some way. Having a family member maybe went through chemotherapy, okay, and that is nothing to scoff at. But when we talk about chemotherapy in microbiology, we are talking about the chemotherapy of simply taking a chemical to treat disease. Okay, so we're going to use chemicals to treat diseases. We like to swallow them, but we can also get them injected and we can get them other ways. Okay, and then at the end of all this, even after we learn about innate and adaptive immunity, we can see how immunizations also work. Okay, so that's in the future, but that's where we're headed, right? We want immunizations for things so we can become immune to these things so we don't need antimicrobials. Okay, so as I mentioned, they are often confused with cancer treatments. Okay, um, and that isn't getting rid of microbes, but it is a chemical therapy, so that is why it is used. But again, in microbiology, we are worried about the microbes. So this all started when Paul Ehrlich, he was one of our founders that we needed to learn about, went to work and wanted to find a magic bullet for syphilis. Okay, and so he found some treatments to treat syphilis, but it was Alexander Fleming's accidental discovery of penicillin and then the subsequent ramp up of penicillin that really shot us into the 20th century in terms of public health. And these chemical agents that we found have select modes of action or mechanisms that they work on, and that's how they work. Okay, um, but we again are primarily used to combat bacterial, fungal, and parasitic infections. Okay, so the heavy hitters of our microbes. Okay, so while we're worried about their um, mode of action and how they use it, and this is where our cell chapter will really come in handy. We need to know our parts of our cell to really kind of understand this section. We also divide our chemical drugs into two different types, okay? And we can see that here. We call them broad spectrum or narrow spectrum, okay? And they kind of work exactly as you would think. Broad spectrum is like casting a big old net, okay? Casting a big old net and trying to see what sticks, okay? And this will kind of not be good for us because it will have an effect on our microbiota. Okay, and we've kind of probably have seen this word a little bit here and there, kind of in the background, biota. What am I meaning by biota? It means the stuff that you need inside you, the microbes that you need inside of you, in addition to all your digestive organs. Okay, and they are actually going to help us in our digestion. They're going to help us in other aspects of our lives. They're going to protect us by being on our skin, as we'll see. So very, very important to learn the term biota, okay? And we have normal gut biota, we have normal skin biota, we have normal eye biota, normal upper respiratory biota, and we'll learn about all of them. And we can also kind of see the parts where we don't have as much biomes, okay? Namely in our kidneys and in our lower respiratory tract, okay? And in our brains, okay? All right, but back to the business at hand is broad spectrum and narrow spectrum. The narrow spectrum then is going to target in on a very specific set of microbes that won't target your gut biome. Okay, so these are very effective against one type of organism or maybe a group of organisms. Okay, but they are not as effective against another thing. And these aren't to be confused with like antifungals and antibacterials, whereas antifungals work on fungi, antibacterials work on bacteria. Those could still be broad spectrum in of themselves and have a broad spectrum version and a narrow spectrum version of those. Okay, so the end of the day on our biota, the broad spectrum has a more impactful case on our microbiota, and the narrow spectrum has a less impactful view. So as a doctor or medical practitioner, you want to be able to limit the amount of damage we do to the person as we are trying to treat the disease. Okay, and that brings us to our term selective toxicity. Okay, agents that harm pathogens but not the host. Okay, that is the key. We want those. Okay, those are the ones that we want to find. Unfortunately, some do target our biota and can make us more sick, but it's kind of like a cost-benefit analysis. You want to measure the side effects versus the actual infection, right? And if you're really, really infected, you give me all you got. So, all right. So, kind of understanding these terms will help us understand our next video a little bit more, in that we know that we have some broad spectrum and we know we have some narrow spectrum drugs. And now if we go into how they work, we can see and understand, oh, that's why it's such a narrow spectrum. Oh, this is why it is a broad spectrum drug, because it works on this and it won't differentiate between the two. Okay, so in the next video we'll get into these mechanisms of antimicrobials, and it'll harken back to our cell chapter a lot, and we can actually uncover what they are targeting and how they help us.